Hello and welcome to our group presentation, and our group will discuss on language and grammar. The content consists of team members, background of study, problem statement, algorithm of the system, interface of the system, analysis of result, programming codes, and conclusion. And now we go through the team members and their responsibility. As the group leaders, I am responsible for coordinate and oversee all aspects of the project, ensures effective communication and collaboration among team members, monitor the project progress and ensure the deadlines met the assignment, manage project resource and address any issues, obstacles that arise.
Hello everyone, my name is Muhammad Hasim bin Abdul Halim. In this project, I am a system designer, and my responsibilities as a system designer for this project is I will develop the overall system architecture, I will prepare detailed design specification and documentation, and lastly, I will design user interfaces, which is UI, and ensure they are user-friendly and meet user requirements.
Next, I will explaining about my roles as system analyst and developer. So, my first responsibility is to study and analyze the project requirements for the PSG analyzer. My second responsibility is to design the system architecture for determining and analyzing the PSG. And lastly, my responsibility is to prepare a detailed system specification and documentation for the PSG analyzer.
My name is Muhammad Hidayat bin Gasran and my role is a system analyst. So my responsibility is to test and validate the system, create comprehensive system specification and documentation for the PSG analyzer, and last but not least, to develop the system architecture for evaluating and analyzing PSG.
Background of study. Our group has chosen question 3, language and grammar, for our group project, which aim to create a program that reads and analyzes phrase structure grammar, PSG. Introduced by Noam Chomsky in the 1950s, PSG is crucial in formal language theory and communication linguistics. Our program will identify the type of grammar in the Chomsky hierarchy and generate accepted strings. Serving as a practical tool for students and researchers in linguistics and computer science, we will use HTML, CSS, JavaScript in Visual Studio Code and build an interactive and educational interface.
So this is our problem statement. Phrase structure grammar PSG is essential in language theory but often challenging for students due to its complexity and numerous components. Manual analysis of PSG can be time-consuming and error-prone, limiting practice opportunities and slowing down learning. To address the issue, our project aims to develop a user-friendly software with a graphical user interface (GUI) that automates PSG analysis. This tool will help students input grammar rules easily, identify grammar types, and generate valid string, thus reducing error and saving time. By providing an interactive and visual learning experience, we aim to enhance student understanding of PSG and improve their ability to analyze grammar pattern effectively.
Hello and good morning to everyone. My name is Muhammad Hasim bin Abdul Halim, and today I want to present to you about our flowchart system. So the first is the start. So the start is the process of the begins, and next is read vocabulary. So in the program, the system reads the vocabulary, which includes all symbols used in the grammars, which is non-terminals. So next is read terminal. This program read the set of terminal symbol, and next it will go to the read start symbol. This program read the start symbol, which is symbol from which derivation starts in the grammars. And next it will go to the read production. The program reads the production rules, which it will describe how symbol can be replaced by other symbols. So next, it will go to the check if left hand side equals to 0, where if the length of the left hand side of any production rule is 0, it will return 0. This indicates that the grammar is unrestricted type 0. Next, it will check if it's type 3 equals to 0. If left hand side is not 0, check the grammar. check if the grammar can be classified as type 3, which is regular grammar. If it is type 3 equals 0, meaning it does not meet the criteria for a regular grammar, it will return 1. And this means the grammar is at least type 1, which is context sensitive. Next, check if is type 2 equals to 0. If the grammar is not a regular grammar, check if it can be classified as type 2, which is context-free grammar. If it is type 2 equals 0, it will return 1, which means the grammar is at least type 2 context-free. Next, check if is type 1 equals to 0. If the grammar is not a context-free grammar, check if it can be classified as type 1, which is context-sensitive grammar. If it is type 1 equals 0, it will return 1, which means it is at least type 1, which is context sensitive. And lastly, it will return 0. If none of the above conditions are met, it will return 0, which means it is unrestricted, type 0. So next, it will go to the determine type. Based on the evaluation, it will determine the type of grammar. There are 4 types of grammar, which is type 0, unrestricted grammar, type 1, context-sensitive grammar, type 2, context-free grammar, and type 3, regular grammar. And next, it will go to the print result. And lastly, it will go to the end of the process. That's all from me. Thank you.
So this is the interface of the system, which is the first one, welcome interface. Welcome to the Phrase Structure Grammar Analyzer PSD system. Next, this is the second interface, which is input interface, where user put the phrase structure grammar analyzer, which is the vocabulary, terminal, start symbol, and last but not least, production. So there is 2 buttons at bottom. The first one is analyze to get the output, and the second one is go to the welcome page, which is the first page. This is the last interface, which is the output interface. After you press the analyze button, the result will be at the bottom, and as you can see here, there's type and string.
Next, we will go to the analysis results. So in this analysis result, I will use a difference of inputs for the vocabulary, terminal, start symbol, and the production, and we can see what the output will be displayed. So for example, I will input vocabulary, and the terminal is A, B, C, start symbol is S, and I will choose these productions. Okay, so this is the production, so we can check it, what is the type of this grammar. So the type is type 0, which is unrestricted. The string is empty strings, ABC, AABC, AAABC, and lastly AAABC. Okay, next I will input a difference vocabulary. So for example, I will put SAB. The terminal is AB. Start symbol is S, and the production is, and we analyze, and we can see that the system will show the result, which is it is the type 2 context free, and it will show us the accepted strings. Okay, next I will choose this vocabulary, which is SAAB. Terminal is AB. The start symbol also same, and the production, and we analyze it, and the type is type 3, which is regular PSG, and it will show us also the accepted strings. Okay, lastly, we use a different input for the vocabulary. I will choose this input. For the terminal, I will choose A, B, C. The start symbol is S, and the production is like this, and we analyze and we will know what is the result. So the result show us it is type 1, which is it is context sensitive, and it will display the accepted strings. So that's all for me. Thank you.
Next, I'm going to explain about the code that we have been using for this project, which is the Phrase Structure Grammar Analyzer. So we are using HTML, CSS, and JavaScript for the project. Okay. So first, this is the head text where it has the title and icon, small icon on the top of the web page. This is the welcome page container. So it has the icon, the details of the welcome page, and then there's also the button when the user click on the get started button, it will call the show analyzer function. Okay, this is the analyzer page container. Okay, where it will have the multiples input text in the analyzer page, and there's also two button. So when the user click on the analyze button, it will call the analyze PSG function. Or if the user click on the go to welcome page button, it will call the go to welcome function. Then this is the script that we written in JavaScript language. So first is the show analyzer. So this is to just hide the welcome page container and to show the analyzer page container. And then go to welcome is the same but vice versa with the show analyzer function. So this is the function of analyze PSG. So we are going to take the value of the text field and then store it into a new variable, okay, according to their name, okay. And then there's also an alert function. So if the user is forgetting to input one of the fields or does not input or type one of the text fields, then it will alert the user to fill in all the blanks or all the fields. And then there's also the loading animation and the output, where the loading time is about 2000 milliseconds or 20 seconds. And then there's also set time out, where each of the input, okay, we will be splitting, where the comma we don't want that, okay, so we are going to remove the comma and take just the symbol itself, okay. And then it's the same with all of that except the start symbol, since start symbols only have one symbol, so we just trim one symbol only, okay. And then we are going to check in the production inputs text fields. If the production input has C, we are going to check whether vocabulary or terminal symbol has C. If not, we are going to put C in the text field itself. And then we are creating a new variable which we call grammar type, where we'll be calling a determine or determine grammar type. I'm sorry about my pronunciation. Where the parameter will accept all of the text field or all the input that have been inputted by the user. Okay. The same as well with the variable accepted strings, where we'll be calling a function called generate accepted strings, where the parameter only accept 3, which is the start symbols, the production rules, and the termination symbols. So then the output content, okay, so for the output it will be shown in the table-like form, okay. And then we have another function which is to get type name, okay, so we are using a switch case for this one. So if the type is 0, then it will return unrestricted, and so on. For the default, we are going to return unknown. So if the type is not one of these, so it's going to return unknown. And then we have determine grammar type function. Okay, so we have three Boolean variable, which is context sensitive, is context free, is regular. So by default, we are going to set all of them to true. Okay, so we are going to use a for loop function. Okay, according how many production rules that has been entered by the user. Okay, so we split each of the production rule to left hand side and right hand side. Okay, and then we are going to check whether the grammar is unrestricted. Okay, first we are going to check whether the grammar is unrestricted. So we are going to use if statement. So if the left hand side has some of the terminal symbols in them, or if the left hand side is greater than the right hand side, so we are going to return type 0 or 0, grammar type 0, which is unrestricted. And then we are going to check whether the grammar is not context free or regular. So if the left hand side, the length of the left hand side is greater than 1, so we are going to set context free and regular to false. Okay, and then we are going to need an additional check for both of them. Okay, if the left hand side, the length of the left hand side is not equal to 1, and or or the left hand side has some terminal symbol, so we are again going to set both of them to false. And then we are going to check if the grammar is regular. Okay, first of all, is regular need to be true, then we are going to find non-terminal symbols in the right side. So this is the coding. Okay, and then we are going to check various condition for the regular grammars. So we are going to check one of the condition. If one of the condition is true, then its regular is true. But if all the condition is false, then we are going to set its regular is false. And then we are going to return the value. If its regular is true, then we will return 3, and so on. And then we have the function to generate accepted string based on the grammar. Okay, so this function is accepting three variable for its parameter, which is the start symbol, the production, and the terminals. So then we are going to create a new set where we call accepted strings, and then we are going to have max interaction and max length. So this is to avoid infinitely looping, because for this function it is using method recursively and brute force. So basically it will loop the production rules to find the strings that will be generated based on the grammar itself. Okay, so this is the function, which is the apply production function. So for the apply production function sorry, it's actually a inner recursive function where the recursion depth exceed, if the recursion depth exceed the max iteration, and if the current string length exceeds the max length, or the current strings consists only of the terminal symbol, sorry, in which case it will be added to the accepted strings. Okay, so for this for loop function, it will again split the production rule into left hand side and right hand side. And if the right hand side has these symbols where we call as epsilon symbols, if I'm not mistaken, then we will press the strings that will be generated for the right hand side as empty strings. Okay, because this means empty. And then for the while loop, it will find all the occurrence of the left hand side. Okay, for the current string. So for each occurrence, it will create a new strings by replacing the left hand side with the right hand side, and then it will recursively call the apply production where it will be create new strings, and then it will be adding depth plus one. Okay, so then this while loop, this process will be continuing until normal replacement can be met or the stopping condition are met. Okay, so then the apply production will be called again, where we'll be accepting start symbol and zero, and then it will return accepted strings in array. Okay, and then it will be sort according to their length. Okay, and if there's no strings generated, it just show no valid strings generated. So that's all for the coordinators for this project. Next, we are going to explain the conclusion that we have gotten from this project.
So the last one is a conclusion. The first one is comprehensive grammar analysis. It's categorized grammar into the four COMSCI hierarchy types, which is unrestricted type 0, context sensitive type 1, context free type 2, and the last one is regular type 3. It generates accepted strings based on production rule and providing tangible example for better comprehension. Next, we have user-friendly design. So it intuitive interface for inputting vocabulary terminal symbols, start symbols, and production rule, and accessible for both novice and expert in formal language theory. The last one is educational and research value. It adds student in learning about formal grammar, help researcher analyze and test various grammar efficiently, and potential enhancements, which is expanding support, grammar type, improving performance, and adding educational resources.
So that's all from us. Thank you for watching this video.